This video is about what we call in Algebra 2 complex fractions. Now, a complex fraction, very simply, is a fraction that contains multiple fractions or rational expressions. The way to simplify a complex fraction is first understand what you're trying to do. So the goal that I always think of is what we really need is we need a fraction divided by a fraction. In other words, we're going to have a rational expression necessarily maybe on the numerator, maybe in the denominator. We need to simplify them so that I end up with a scenario where I have a fraction divided by a fraction. All right? So the steps are very simply this. We're going to simplify the fractions in the numerator to a single fraction. We're going to simplify the fraction in the denominator to a single fraction. Then we're going to divide the two fractions. You can either use the division algorithm that says change the division to multiplication, flip the second fraction, then multiply. Or the way I like to do it is I do big C, little c. All right. And then finally, if necessary, simplify. So if you can simplify, simplify. For this particular section, let's not worry about restrictions. All right. They do exist, but let's not worry about them. In this first problem, notice what I have here. I have a fraction divided by a fraction over a fraction. This is exactly what I was referring to as a complex fraction. Now, the way that I like to do it is I multiply big C over little c. This is the same, and I'm going to show you here in a second. If I take 1 times 2, I get 2. If I take x times x, I get x squared. That's the final answer. This works the same way as the division algorithm. So if I were applying the division algorithm, I would change the division to multiplication, take the denominator, flip it over, and then multiply, and I still end up with the same thing. I think that big C, little c actually speeds up the process just a little bit. But keep in mind, this only works when you have a fraction equal to a fraction. So in this next problem, I have a fraction, not equal, divided by a fraction. Okay? I'm going to write out my arithmetic by following big C, little c. I have x times x plus 3 divided by 2 times x plus 3. And when I write this, I notice I could distribute, but I don't know why I would, because what I'm looking to do is see if I have any common factors. If I notice right here, these x plus 3s are going to cancel out, so my end result here will be x over 2. All right? But what happens when you get a numerator like this? Or for that matter, a denominator. Well, I still have a fraction divided by a fraction. But that numerator, I need to simplify into a singular fraction. All right? Now, in the numerator, I'm adding things that have the same denominator. So I know that told me back in addition that all I have to do is add their numerators. So I'm going to rewrite this as 6x plus 2 over x minus 4. And then I'm going to divide that by the denominator, which is already a singular fraction. Okay? When I have this scenario, now I'm going to use my big C, little c. So that's going to leave me with 2 times 6x plus 2 over x minus 4 times 3x plus 1. Now, I could multiply things in and then simplify, but one thing that I recognize is in the numerator, I have a GCF up on top of 2. I'm going to pull the 2 out of the numerator and put it together with the 2 that's already out there, leaving me with 4 times 3x plus 1. Did a little GCF factoring there. All right? Denominator, I'm just going to leave it in factored form. And when I have it like this now, I notice that these binomials are going to cancel out. So my final result would be 4 over x minus 4. All right. Another one where we're going to need to adjust the numerator, but this time the numerator does not have the same denominator. All right. So from the numerator, I'm just focusing on the numerator right now. This is why they call these complex. There's going to be quite a few steps here now. From the numerator, I know that my LCD here is x plus 5 times x plus 2. I play the game. I have x squared plus 2x is given. In the first fraction, I'm missing x plus 2. Minus x squared, that's my given. In the second fraction, I'm missing the LCD of x plus 5. All right, I'm going to clean this up. So this would be x cubed plus 2x squared plus 2x squared plus 4x minus x cubed minus 5x squared. So let's see, when I combine like terms here, I have negative 1x squared plus 4x. And I'm going to go ahead and factor this to negative 1x times x minus 4. All right? All that work was simplifying the numerator. Now don't forget, this is still being divided by the LCD, x plus 5 times x plus 2. All right, now I have to divide that, go back to the original problem, by x plus 2. But as I said, I always want to look at this as a fraction divided by a fraction. So I'm going to make this into a fraction by putting it over 1. All right, I do big C, little c here. Big C, little c. All right, and that's going to give me negative 1x times x minus 4 divided by x plus 5 times x plus 2 times x plus 2. I notice there's nothing to cancel, therefore this would be my final answer. You don't have to worry about multiplying it all together, although you could. You could multiply it all together. All right. So, what if I give you a problem like this? Well, in red, I'm going to simplify the numerator. I know it has an LCD of 3x squared. I'm going to adjust the numerator, so I have, let's see here. Let me make sure something real quick on this one. Yep, we're good. Okay. Sorry, I had to double check myself there. All right, so let's see. I have 4 times I'm missing 3 minus 2 times I'm missing x squared, which would simplify to 12 minus 2x squared. Now I'm going to rewrite this as negative 2 times x squared minus 6. Okay, bring in the LCD of 3x squared. All right, I know I'm going to have to divide this by the way that the denominator simplifies. With the denominator, I notice I already have a common denominator, so it's really 2 minus x over x plus 3. I'm going to rewrite that numerator, though, as negative 1 times x minus 2. And the denominator is x plus 3. All right, I'm going to do big C, little c here. big C, little c. That's going to give me negative 2 times x squared minus 6, which I can't factor, times x plus 3, divided by negative 3x squared times x minus 2. All right, the only thing that I noticed that I can simplify here is get rid of those negatives. So I'm going to write my final answer as 2 times x squared minus 6 times x plus 3 divided by 3x squared times x minus 2. I hope this helps. Let me know if you have any questions.